Hello, my name is Princess Rose Balasico. I'm in Honolulu Community College in the PEEC2 program, summer 2020. In the past 6 weeks, I've been researching about the Sea Glider. It is an autonomous underwater vehicle, AUV design, and gathering CTD data, which is conductivity, temperature, depth, is what you see in Figure A. It weighs less than 60 kilograms, 2 meters long, and it has a hydrodynamic shape, so it has a buoyancy float that goes through the water. When it sinks, it sucks in water, and when it floats, it pushes out water, and it rises to the surface of the ocean. It is a vehicle that only connects to a satellite that can give information on what it's been gathering for months at a time. It is cost effective, and it has internal sensors to control depth and altitude, and external sensors for water ocean properties. For this research, I've been doing a smaller scale of it, a size of a water bottle. It doesn't connect to the satellite, so it has a remote control, which makes me able to move if I wanted to go down or up, and also has a pause button and number 2 button, which controls the balance of the Sea Glider. My objective was to fully assemble it from the kit. It was to assemble it from scratch, then to run some test trials to see if the water bottle is waterproof. It has no leakage that goes through to the machinery. The next was to attach a waterproof camera, like a GoPro as such, to see what the Sea Glider sees underwater. Next was a water sensor to test salinity, which is one of my experiments, in each depth of the ocean. The materials I've been using was the Sea Glider kit, which is in material 1. Material 2 is the soldering tools and supplies. This contains the flux, and then I chose the lead-free solder and the heating tool. Next is the material 3, which is 2-part epoxy, wire cutters, pliers, and scissors. The method was to build the Sea Glider from scratch, then program the Sea Glider using Arduino, and after was to waterproofing the bottle, and then field testing it, which is to test it in different types of beaches. My results is that when building the Sea Glider, it went from each section. It had different bags for different steps, and then when you put it all together, it becomes one, which was really fun for me. I had to learn how to do soldering and why it's important to put each wires on a specific slot in the circuit board, as you can see in the first image. And then the second image is putting it all together. The syringe is the engine that sucks in water and sucks it out. After, I didn't realize you need to use Arduino programming to start the machine itself. When I pressed the push button, it did nothing but lighting up because of the battery. So when programming, it was working well. Sorry about that. Also, it was important for me to waterproof it because the instructions that's given me in the site from getting the kit, it had videos and pictures, said it would give me a 2-part epoxy in the kit. Fortunately it did not, so I thought of putting hot glue instead. And just to make sure, was very cautious about using hot glue or not. I had to ask for a 2-part epoxy from one of my instructor, and the first layer didn't go well, didn't mix thoroughly, so I did another layer, so 3 layers, to waterproof the water bottle, and it went very well. The first place, the beach I tested, was Sand Island Park. I placed it where tide pools were, and so it was guarded by rocks, so it doesn't go anywhere to fly. Also, I attached a rope to the Sea Glider to double make sure it doesn't go anywhere as well. Overall, in this experiment, the beach, I the remote connection wise to the sea glider, it had to be very close to the remotes in order for it to work, but it hasn't worked. Only thing that was working is the pause and play button. Try to let it go down, didn't work. Try to let it go up, didn't work. So yeah, it wasn't functioning what it's supposed to be functioning with. Before going to the next test site, I was just analyzing what's the problem, and I realized that it could be not a fully functioning battery, because I've been using the battery to program it. It took a little while for me to do it. So maybe it was that. And in the testing site, if the Sun Island waves were a little harsh for a sea glider, so maybe that's why there was no movement going on, or maybe there was very little that I didn't see in my eyes. So I replaced the new battery and went to calmer waves, and the calmer waves were in Magic Island. That was my second testing site. And for the results for this, it didn't work again. It's the same pace as the last Sun Island testing site. It's with the fully charged battery. Before even setting it to the waters, the syringe was sucking in, sucking out with the air, so it really worked before the waters, but then after it didn't. But one thing happened, which was the syringe actually sucking in, sucking out just once. Unfortunately, it was just air it was sucking in, so didn't know the problem in that. And due to the quarantine lockdown, another one, I couldn't able to go to different types of beaches, so I just had to find what's the problem with the sea glider. There only been two things that I come up with my peer mentors, which was burping the sea glider, which is one of the checklists to setting it out to the ocean. It is to push out the air that's really compressed in the syringe so the water can go inside, which I haven't done that, so I would definitely do that to my future work. And the other would be the buoyancy engine. Since it did suck in and suck out, it didn't move at all. It could be the buoyancy engine, and I couldn't test the buoyancy engine for that due to the limit time of this research. In conclusion, my objective was to attach a waterproof camera and a water sensor. That hasn't happened in 6 weeks due to troubleshooting the sea glider itself. But the buoyancy engine will look upon to, and also burping if I have another testing site to place the sea glider in. Just building a sea glider was really fun since it was my first time doing engineering wise stuff. Soldering was my favorite thing to do. It took a while, but it was so cool to do, and I was becoming more aware with programming codes, since the programming Arduino also had other press buttons on the remote that I could make command controls. I realized that you have to find specific codes to put it in, like milliseconds in this direction or that direction. I understand how codes are, so in my future work I would, and for fun, to understand how to do codes, and hopefully it could impact with my sea glider. My future work would be fixing the buoyancy engine, then attaching the waterproof camera, inserting the water sensor, then to have an experiment to gather water samples in each depth and a specific beach to test the salinity, which was my objective overall. Here are my references. Figure A and Figure B was the pictures that I haven't made but got them from these websites, and also my other websites of getting information about the sea glider and the Adreno. Acknowledgement showing my deep appreciation towards Shidong Khan and the program coordinator Catherine Bronston. I also want to thank my peer mentors Mia, Leo, and Anthony, and also Honolulu Community College to provide a PEEC2 program for letting me touch the surface of environmental engineering, and NSF who gave us the experience to do so in this system. That is my presentation. Thank you.